Hello everyone. In this video, we're going to cover bad hole identification and repair. In this video, we'll cover the methods available for flagging bad hole or washouts, and how we go about setting the method for repairing bad hole. So here we are in the My New Project that we created. And right now we're on the setup module. So we want to first of all do two things. First, we want to ensure that we're on our key well. And now we want to come here to our project selection or our module selection menu, and we're going to select bad hole ID and repair. This is the third option down in the list. Okay, so now we have this interface, and we have a number of log displays, and we can see that by default, we have one option of activated, and that's the apply row B bad hole minimum. And we have the parameters available for that. So real quickly, I just want to cover all the options that we have available. First, we have a caliper bad hole. And so this uses essentially a cutoff on the caliper to identify zones where you may have washout. So for example, here, if we turn on our apply caliper bad hole max, we can see that this interval exceeds the caliper maximum. And so therefore, this would be flagged as bad hole or washout. Now, one of the cautions for using caliper as a washout indicator is that this works fine on a single well, but when dealing with large projects, caliper depends on the bit size that was used. So in some wells, you may have your target interval drilled with 9 5/8 inch drill bit, or maybe drilled with a 7-inch drill bit, and so that's going to affect your caliper size. So a lot of times, instead of using something like the caliper, we try to use other methods. So for example, we have the caliper rugosity, which is displayed here in this track, and what this is, it's quite simply an illustration that tries to show us the difference between the measured caliper and a smooth caliper. And this works quite well for identifying washouts. We can also use the a minimum cutoff value for our density. We can use the D-row curve as well. So to set these, we can either drag and drop parameters, and you'll see that as I move the parameter, it changes here in our parameter table. Or we can come in here and we can type values in. So here I'm just going to set my default value. This is an Austin chalk interval, so it's very rare that we have low densities in this interval. So I'm going to come to my Austin chalk, and maybe we say something like 2.35 in this case. We can see that we're flagging more washout there. And for our D-row max, once again, we can either drag and drop the parameters, or we can type those in. And we see that as we do this, we're flagging increased washout on our density curve. So now that we've washed out our, flagged this washout, if we don't do a repair, the density curve will be null through these intervals. That's probably not the desired behavior, as we'd still like to make an interpretation. So now what we'll do is we'll select this repair density option, and it'll give us the option for our curve repair algorithm. And we have two choices. We have MLR, which is multiple linear regression, and we have our random forest. The default is MLR, and the reason that's the default is we've done a number of studies that have shown that the MLR is both, one, significantly faster, and two, marginally more accurate than the random forest. However, you will notice that in many cases the MLR does not appear to have as much character as the synthetic or repaired curve generated by the random forest. So if aesthetics are important to you, it may be worth experimenting to see which choice you would rather have. And so as soon as we do that, now you can see, and let me turn that back off. So we're gonna turn off repair, and I want you to focus on this track here. And especially, let's zoom into this interval. So this is where we have that washed out density, and in black is our original density curve. I'm going to hit repair density, and now we see this red curve appear and shading in between the black curve and the red curve, and that's showing us where we have made the repair. And we can see that we've made quite a repair here. However, maybe there are some intervals that we missed. So one of the things that we often like to do is we like to pad out our bad hole flags, and this really just expands those out a little bit. So now we can see that we're repairing an even larger curve interval. So example, this whole interval here. Now you will also be faced with the additional question, do you wish to do the same for your PE curve, your neutron curve, and your density curve? Since PE and density are measured using the same pad on the same tool, generally what we'll do is we will apply the same bad hole flag to the PE curve that we apply to the density curve. So I'm just going to select that option, and I'm going to click Repair PE. Now in this well, we actually don't have a PE curve, which is why nothing is showing up. However, in non-key wells, perhaps we do have a PE, so we want to make sure that that is repaired. And then you'll have the question of, do you want to potentially repair the neutron and sonic curves? If you do, you'll need to click Apply the bad hole maximum. This will bring up the parameter entry box for the neutron curve, and then you can come in and set that value. However, in this project, I know there is very little washout in the neutron, so this is something that we don't really need to do. However, if you want to do it, there's no harm. We can set that, and we can do the same for our sonic curve. So really the interface is the same for each of these curves. You can flag washout via drag and drop, and you can choose your repair model for each. And so that is how we set our bad hole and how we determine what the bad hole value is moving forward. So just as a reminder, here in the density curve, where there is no washout flagged, we will we'll use the original density curve values. However, if washout has been flagged, we will reconstruct that curve using an MLR or random forest technique, and we will apply that synthetic curve over the interval that's been flagged as washout. And as always, once you have set up your parameters as you like them, remember to save your project and then continue on. Okay, I hope you enjoyed this video, and look forward to next time.